Alkynes. Alkynes are similar to alkenes in that they are unsaturated. They contain at least one triple bond between two carbon atoms. As a result of this, they're actually linear in this portion of their carbon chain. So naming alkynes is exactly the same way as alkenes. The number indicates position of triple bond. And the suffix is YNE because these are alkynes. Drawing them is exactly the same rules for alkenes as well. You make sure that you draw your longest continuous carbon chain containing the triple bond. Put the triple bond in when the number indicates it, just in front of the suffix, and then add your side groups if necessary. So same rules as alkenes. Okay, let's name these two alkynes. Longest carbon chain is right here. So that's 4. Triple bond happens after carbon 2, no matter which end you number it from. So this is but 2-ine. So but 2-ine. Now this one is a little bit different. It's a little complicated. Here's our triple bond. So let's start from this end, which is closest to it, and see if we can find our longest continuous carbon chain that contains that triple bond. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. All right. So our longest carbon chain is 7, so it's hept. Carbon triple bond occurs at carbon number 2. So there's our root and our suffix. That's our parent chain, the 7. So that means that this group here and this group here are side groups. So one contains 2 carbon, the other contains 1. So we've got an ethyl and a methyl group. So ethyl goes first because E comes before M. So ethyl, and then methyl. And now put in the numbers telling us which carbon these side groups are on. So carbon 4 has our ethyl and carbon 5 has our methyl. So the name of this compound is 4-ethyl 5-methyl hept 2-ine. All right, let's draw some structures. Propyne. Okay, so this is telling us the root, the suffix, but there's no number. So it's telling us it's 3 carbons in a chain, and there's a triple bond. But because there's less than 4 carbons, there's only one place that triple bond can be, and that's after carbon 1. Because it doesn't matter if you draw it. Either way, the triple bond comes after carbon 1. So put in a triple bond. Make sure each carbon has 4 bonds. Then put in the remaining hydrogens. So there's propyne. Pent-2-ine. So this is telling us our longest carbon chain has 5 for pent. And it's saying that after carbon 2, we have our triple bond. So each carbon has to have 4 bonds. So add lines to make 4 bonds for each carbon. Then put on your hydrogens. And there you have pent-2-ine, otherwise known as 2-pentyne. Physical properties of alkynes, same as alkenes and alkenes. They are nonpolar because they contain nonpolar bonds. Therefore, they're insoluble in water, can't form hydrogen bonds or accept hydrogen bonds from water. Some of them will have higher boiling points than their corresponding alkanes, same chain length alkanes, because of their linear nature. It allows them to get closer together, but that's only for smaller chains. So smaller alkynes, slightly higher boiling point due to straight structure or linear structure. Allows them to get closer together. Again, we only have London dispersion forces, so they're still fairly low.